Morning. We are finishing off 6.1 problem 1 today, looking at 6.1 problem 3 and talk to talk. We are starting on page 377. All right, my friends, 377. Guillermo, can you take your headphone out of your ear, please? Thank you. I got a lot of calculators up here. Do you guys have calculators?
We got a lot of people missing.
I guess if nobody's gonna take these last four, I'm taking it.
Okay. I already turned it on. Okay. Good. We'll just wait for them to turn in. Oscar has calculators. All right, if I could have your attention up here, please. Kenya. Oscar, have a seat. Brian. I need eyeballs up this way. Okay, we are finishing off lesson 6.1 today. Oh, there they come. And we are going to have a test on Friday. Okay, so we've been talking about systems of equations. That's in chapter 6. We also, before that, in chapter 5, looked at simple and compound interest. So your quiz will have a little bit off of both. And actually, I called it a quiz, but it turned out to be more of a test. So there will be a partner test to get ready tomorrow, and then a test on Friday, something to look forward to. Today, we're finishing off new and starting a little bit of review, and hopefully we'll have some time, too, to look at that homework packet, and you can work on it with the calculators. Announcements. Sophomores have concession today. I don't know if there's any sophomores out here, but they could use some help raising money for their class. Also on Friday, there's going to be a glow rally, and you're going to want to wear white if you can. You're going to try and get the whole stands wearing white. So think about what you may have that you can wear on Friday that's white. Okay? Now, 377, partway down the page. Not all systems will be written in slope-intercept form or function notation. Some systems can also be written in standard form. Standard form, take a look at this. 2x plus 8y. That's standard form. Make sure it's focused. That's standard form because you have the x and y both on the same side of the equation. Notice also, we've been approaching this by getting things into y equal form. Oscar, this one will be a little bit hard. This one will be a bit harder if we wanted to get it into y equals form. So we're going to learn a new way as an option. And we'll look at these two, but I want to look at Maria first. Take a look at what Maria did. In order to solve this system of equation, she split them off into two, one on one side, one on the other. And then what did she do? Look at the little blue box that says Maria. What do you notice about how the equations have been rearranged? She took one equation, put it on the left, One equation, put it on the right. Y equals. So y equals on this side here, and y equals on that side there. But look at this equation. This is what we've been doing as a process so far if we wanted to solve algebraically. Moving things to make them y equals, then taking this piece and that piece and putting them together. But look at that equation. Does that look like that'll be fun to solve? No. Why not? Fractions. All right, so you're saying there has to be a better way, yes? Yeah. Now, if you have equations that are easy to put into y equals form, that's what we've done. We've put them into y equals form, and then sometimes we put them into the calculator and graphed them. Other times we set them equal to each other. Now look at what Dontrell and Janelle did. They did something different. Instead of y equals, what do you see?
They put like, they said x equals something, and then they plugged that in for wherever x was, or vice versa, wherever y was, like in Dontrell's.
So in Dontrell, he got y by itself, and then took this expression and plugged it in to the other equation. Janelle said, I don't like y, I want to work with x. She did the same thing with x. She got x by itself and then took what x was and plugged it in to the other expression. So instead of always getting both of them into y equals and then setting them equal to each other, there are two other options. We'll look at how those work and which equations you might want to do that for today. Okay, flip the page. B. Describe the method Janelle used to solve this system of equation. Why is her reasoning correct? Oh wait, maybe we should back it up and do the Dontrell at the bottom of the page. That'll make the next two make more sense.
Look it up, Andy.
Dontrell. No, you're a distraction, right? Could you read A, please, Brody?
A. I thought we put.
We did, sorry.
Describe the method Dontrell used to solve this system of equations and explain why he used it.
Okay, Dontrell, here's this guy up here. What did he get by itself? He got y by itself. Then what did he do with it?
Plugged it in.
Then he plugged it in for y. Okay, so this is a different kind of substitution where he had 2x plus 8y equals 20. Instead of y, he has this expression. Can you do that? If y equals that, then can we switch them back and forth? What do you think? Andy nods. Imogen says yes. If y equals 4x plus 2, can I sub them in and out for each other?
Yes.
Yes. If things are equal, small and at the bottom of the page, you can substitute. Okay, it was a different looking substitute than we'd done before. B, we're looking at Janelle. What did she get by itself? She did something similar. Got x by itself, substituted. into the other expression. Can you do that? Yes. If things are equal, you can substitute. You can trade pieces in and out if they are equal. They might look different, but if we can show they're equal, they stand for ultimately the same thing. It's like in basketball. I can trade one player in for another player. They hopefully go on the court and do the same job. Okay? So substituting is trading things back and forth, and it could be an x, or the expression that x equals. It could be a y, or the expression that y equals. Describe how Maria solved it. She was the last one. What did Maria do? You guys flip back. I'll keep to this page. What did Maria do? Did she get x by itself?
Got y by itself.
She got y by itself. Then what did she do? Got y by itself for both. Both of the others were only working with one of them to get the variable by. Ah, bless you. Okay. Then she set them equal. This is the method we've been using. We've done that like 3 or 4 assignments already. So we know that method works. Why did it look harder this time? Fractions. You can do this, but harder. This one was harder. Or it looked like it would be harder to move through the next phase of finding out what the x is. Which method would you prefer? We've got a system of equations, 2 equations. We want to find out where they crisscross. What would you prefer? All 3 were substitution. Whose do you like?
X and y by itself. The ones that you plug it in for that's from that.
Imogen likes getting x or y by itself. Use one of the methods shown or your own method to determine the solution. All right. I am going to flip back. We got to pick one of these and take it further. Am I liking Dontrell, Janelle, or Maria? Dontrell, I'm hearing Dontrell.
Yeah.
2x plus 8 times 4x plus 2 equals 10. So that's as far as he got it. He didn't actually solve, he just started it. He started it by taking something that looked like this, 2x plus 8y equals 10, and that y got replaced. So now we have a kind of a bigger expression, but we know what to do with that. What do I do with an 8 out in front? Yeah, Jerry? Distribute. Times here and times there. 8 times 4, 8 times 2. Now, ultimately what I'm trying to do is get x's on one side, numbers on the other, so I can find an x equals. Memo, look at this. 2x and 32x. What can I do with those? What? Well, here's a 2x plus 32x. I underlined them to help you know they have something together. Kenya wants to help you. Should she help you?
Yeah.
Have her tell you what she's going to say.
You can combine the x's together.
you can combine them. They're x's, and they're all on the same side of the equal. So this is 2 plus 32. What's that, Memo?
Huh? What?
2 plus 32. Try again.
34.
There we go. 34x plus 16 equals 10. Again, we're trying to get x's on one side, y's on another. So I have a plus 16 I'm going to want to move. Christian, how should I move that? Thank you. It's a positive, so I want to cancel that out by subtracting. Goodbye. Plus, minus, they cancel. That leaves the 34 by itself. Equals negative 6. I'm going to divide by 34, divide by 34. That doesn't divide, but it does reduce. Negative, let's see, I can divide them both by 2, 3 over 17. Whew. Now, we're supposed to go find out what y is, but this is looking ugly. Let me see what I can see over here. All right, here's what we're going to have to do. Y equals. Remember that we substituted by getting y by itself from one of those expressions. That's going to be the easiest one to plug this ugly number in. So I'm backtracking. Oh, it's going to be 4x plus 2. That was one of the rearranged versions of the original equation. Y equals 4. Now, we always find one variable and then have to plug it in to find the other. Negative 3 over 17 plus 2. You're saying, Rigetti, don't make me do one of these on my own. Okay, deal. But it's good to know. All right, I have 4 over 1 times negative 3 over 17. Negative 12 over 17 plus 2. Now I got to add. I need a common denominator. Put the 2 over a 1. I'm going to times the top by 17 and the bottom by 17. Why am I doing that? Common denominator. When we add, that's something we need to do. This turns into 17. What's 2 times 17? 34. Okay, so now I have negative 12 plus a positive 34. Excuse me?
22.
Thank you. Y equals 22 over 17. Here's my x and the y. So those two don't crisscross nice and pretty on a graph anywhere on the grid, but those are numbers you may come up with at some point. Okay? Whew. That's probably out of time on this. Let's